Hello everybody and welcome to the Bowtie Teacher. I'm Rob and in this video I'm going to be taking you through the Year 8 progress test for November. Let's get started. So here we have the Year 8 November test topics and I'll be taking you through them one by one so that you can see the areas that you need to practice. So the first one is probability, and what we need to make sure that we understand for probability is that all probabilities add up to 1. So that means if we have maybe the probability of someone being late to school is 0.3, then the other possibility is that you're on time. So we can work that out by subtracting 0.3 from 1. Similarly, if we have maybe a bag full of red, blue and green discs, and the probability of red is 0.2, probability of blue equals 0.5, and you're asked to work out what's the probability of getting green, then we would simply subtract the other two from 1. So 0.2 plus 0.5 is 0.7, so 1 minus 0.7 is 0.3. Okay? And we can use these probabilities later in a question. Now, we would also be expected to do probability trees and fill those out based on what's in the question. So if we use this example of lateness, then the probability of being late is 0.3, probability of on time 0.7, and for the next day those probabilities wouldn't change, so they're not really dependent on each other. So we can put late here, on time, late, and on time like so, and just filling these probabilities. Now if we head on over to bowtieteacher.com, I've created an app on the GCSE Mathematics page which is relevant to this particular topic. So if we just maximize this and we go to start, you can log in and sign up if you want to track your progress. We can go to level 4 and we have some probability here where it will give you the probability of a team winning is 0.24, and you can fill in the rest of this probability tree. So 0.24, we would work out what the probability of losing is, which is 1 minus that, 0.76. So you can fill in 0.24, 0.76, 0.24, 0.76, like so. And then at the end, it's asking you to work out the probability of a win-win. And when we do that, if we're going down these branches, then we multiply as we go down the branches. So probability of late would be 0.3 times 0.3 because we're going down this particular branch here. If we want to do the probability of being late then on time, we will go 0.3, 0.7. So we multiply those two together. This one here, on time and late, would be 0.7 times 0.3, and on time is 0.7 times 0.7. You can work all of these out: 0.09, 0.21, 0.21, and 0.49. And when we add all of those possibilities together, we should again get 1 because all the probabilities add up to 1. So this is a way for you to check your answer at the end, is to make sure that these add up. So 49 and 21 is 70, 0.70, 0.91, and then the 0.09 just does give us 1. So they add up to give 1. On the app, we can multiply those two together for each of these, and then we can check our answer again at the end once we've filled that in, just to practice filling in the probability trees. Our next topic is ratios. So with ratios, what we need to do is to make sure that we add up the ratios and we can divide into a certain amount. So if we have £70 and it's divided in the ratio of 3 to 4, then we add the ratios, 3 plus 4 to give 7. So we have to divide our original into 7 shares. So we do 70 divided by 7 equals 10. So each share is worth £10. This person has 3 of those, so 3 lots of 10 shares, and this one has 4 lots of 10. So we get £30 to 40. And at the end, we just double check that they add up to our original amount up here. Okay. The alternative to that is that we might have, say, £100 for one person who's in the ratio of 3, no, not 3, we'll do 4 to 5. So if this person has 100, how much does this person have here? So we have to determine how much we have to multiply 4 by to get 100. So that's times 25. So this person would have times 25 as well. So 5 lots of 25 is 125. So sometimes we have to scale up the ratios like so, or sometimes we have to divide an amount by a given ratio as well. If we head back onto the app here under level 5, we can practice some ratios here. So we have £5,448 in the ratio of 5 to 3. So we would divide 5448 by the total of the ratios, which is 8, and then that would give us the total for one share. We multiply that by 5 to give Martin's, and we multiply by 3 to give Leanne's. And you can practice how much Leanne would receive. You would type that in there and check your answer. And you can keep practicing those until you feel comfortable with that. Our third topic is indices, and this is building on our work from year 7. So if you're not sure about indices, then check out my year 7 video in which I go through this in a lot more detail. But essentially we have 4 rules where we can add the powers when we multiply like so. And if we do a division, x to the power of 6 divided by x squared, we subtract the powers to give us x to the power of 4. Anything to the power of 0 equals 1, and anything to the power of 1 is itself. And then what we do when we get to the higher levels is we start to combine these. So if we had 2x cubed times 3x squared, students often get a little bit confused as to how we go about these. So what we will do is we will treat the numbers separately. So 2 times 3 is 6, and then we would do x cubed times x squared. We would add those powers to get x to the power of 5. So 6x to the power of 5. We don't add the 2 and the 3 because students think, oh, we're adding the powers, so we're going to add the 2 numbers here, but we multiply those and we add the powers. Similarly, if we had 12a to the 6 divided by 3a cubed, then we would divide the numbers. 12 divided by 3 is 4, and a to the power of 6 divided by a cubed, we would subtract those powers to get a cubed. There may be more difficult ones where we have a fraction, so let's try 4a squared times 3a cubed divided by 6a to the 4. So again, try to pause this video and see if you can answer this question here. Okay, I hope you have the chance to do that. We would do the numbers separately. So 4 times 3 is 12, divided by 6 is 2. A squared times a cubed is a to the power of 5 because we add those, and we're dividing by a to the power of 4. So we subtract the powers to give a to the power of 1. And remember from this rule here, a to the power, oh sorry, this rule here, not that one, a to the power of 1 would just be a. But you wouldn't lose a mark if you left it like that. For HCF and LCM, again, this is very, very similar to our Year 7 work. So if we had 100, we would use the cherry trees to break this down into its prime factors. So 100 equals 2 times 2 times 5 times 5. Or 2 squared times 5 squared. If we have 80, then it would be 2 and 40, 2 and 20, 2 and 10, 2 and 5. So 80 would be 2 times 2 times 2 times 2 times 5, or 2 to the power of 4 times 5. So this is expressing these as a product of its prime factors. Remember, product means times, and prime factors are the ends of these cherry trees. Now, what we'd also have to do is work out the HCF. So we had 100, and that was 2, 2, 5, and 5. And 80 was 2, 2, 2, 2, 5. What we can do is we can score out these that are paired up. So a 2, a 2, and a 5, like that. So our HCF are the middle numbers, the intersection of these multiplied together. 2 times 2 times 5, which is 20. And then the LCM would be the HCF, which is 20, multiplied by what's left over. So we have a 2, a 2, and a 5. So we've got 200 times 2, which is 400. So LCM is the first number that is in the 100 times table and in the 80 times table and overlaps. Now, in your exam, you might have some more difficult ones of these, but try to follow the same principles and apply your knowledge in a new situation. So if it looks a bit strange, but you're asked to do HCF and LCM, just use this information that we've done here, putting the ones in the middle that are overlapping and doing the LCM from the ones that are left over. If it's a non-calculator paper, then you have to think of a way around that as well. Finally, we have standard form. And if you recall, a standard form number must have something times 10 to the power of something else. And this number should be between 1 and 10. It can't actually be 10, so just less than 10. So if we have a number like 148,000, we have to try to find a decimal point which will give a number between 1 and 10. So we couldn't have 148 or 14.8, we would have 1.48. So we would write 1.48 like so. And don't try to round this at all. Don't try and make that 1.5. Keep it as the number of significant figures within the question. And how many spaces did we move the decimal point to get to here? We would move that 1, 2, 3, 4, 5 places. So this is how we move from a normal number to standard form. And to go the opposite way, if we had 3.2 times 10 cubed, then we would move the decimal place 1, 2, 3. So let's just write this 1, 2, 3. The decimal point would be there, and underneath these arches we put zeros. Okay, so that's the basics of standard form, is converting normal numbers to standard form and back again. We might have to do some addition or multiplication of standard form, or even some division, and without a calculator we have to understand how we can do this in a written form. So if we had these two numbers added together, then we would have to turn them into a normal number, add them together, and then convert them back into standard form. So 148,000, and then we have 3,200 like that, and add them together. So we have 151,200. So again, 151,200. We need a decimal point, which is going to give us a number between 1 and 10. So 1.512, 1.512, and we would go 1, 2, 3, 4, 5 spaces, like that. If we have to do some multiplying of these standard forms, like 1.2 times 10 cubed, multiplied by 2.3 times 10 squared, then you wouldn't really want to turn these into normal numbers and then multiply them, although you could do. What you want to do is multiply the 1.2 and the 2.3 together separately, and then the 10 cubed times 10 squared separately. So the powers one from our earlier work, we just add these powers, 3 plus 2. And we would multiply these together and add them up, and then put our decimal places in like this. So what we have here is 2.76 times 10 to the power of 5. Okay? Sometimes we get a number here, like say the number was 12.3 times 10 to the 4, then this number here is no longer in standard form because we have a 12 here instead of a 1.23. So we would have to turn that into 1.23 and then increase the power by 1 so that they're the same number. And you can check that if you like by putting the arches in and making sure that you get the same number here. But if you move the decimal place 1 to the left, you increase the power by 1. I hope that's helpful for you. We do have the bowtieteacher.com website for you to practice ratios and probabilities, which will help you, as well as indices. And I'll just show you from level 3, we have some prime factor decomposition. So you can practice breaking 60 down into 2, 2, 3, and 5, and you can check your answer and it tells you you're correct. And you can keep practicing these so that you're comfortable with that. So refer to the website, and if you have any questions, then please comment below and I'll do my best to help you out. Good luck in your test.